Hello everyone, I am Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics Model of the Atom. So today we'll be looking at how people thought atom looked like in past and how we got the model of the atom that we know so well today and what it is exactly. So we'll be talking about some experiments that led to it, especially the Rutherford experiment, which is actually probably the most important in this topic. And so, without further ado, let's get started. So, first of all, initially people thought that, initially people didn't know what atoms were, but eventually the atoms were discovered and various models were proposed, but the most recent model that was widely accepted before our current model was Plum pudding model. Now, Plum pudding model assumed that an atom was a sphere, it was a spherical particle, and it consisted of large area, positive sort of mass area, and then it had small concentrated areas with negative charge, and hence the name plum pudding, whereby the positive charge is the pudding in the bowl, and then the negative charge areas that are small plums inside the bowl. So that's how plum pudding model was brought about, and it was widely accepted until certain experiment, i.e. Rutherford experiment, has essentially disproved that model. Now, before we move on to the experiment, let's have a think about what is the current model of an atom. What does atom look like currently? Well, the current model of an atom is a high nucleus with a high mass, and that nucleus is positively charged. That's where all the positive charge and most of the mass is concentrated. And then we have particles outside orbiting that nucleus at set distances that have a negative charge, and they also have a very, very low, almost negligible mass. Now, this is a very different model to plum pudding model, and how did it come about? Why did we jump so drastically from a plum pudding model to a nuclear model? And that is thanks to Rutherford experiment. And Rutherford devised this experiment here to try to explore what atoms really look like. And it's a really good experiment because it's very indirect in a way. It is a very simple design, but it actually tells us a lot about what atoms look like in reality. So here's the experiment. We have an alpha transmitter releasing, it's shooting out alpha particles. And in front of that transmitter we have a golden foil, and around that golden foil we have a film. So essentially the transmitter is shooting alpha particles, and the particles essentially either go through the golden foil or they get deflected. And when they hit the film, when you develop the film, you will see a hit. You will see where the alpha particle hit on that film. So, knowing this, we know exactly whether the particles went through, whether they were deflected, and exactly by what angle those particles were deflected. So, relatively simple design compared to some of today's experiments, yet this experiment taught us a lot. Now, what were the results of this experiment? The results of this experiment was that most particles went through. Most alpha particles were shot at the golden foil, and they passed straight through, hitting the film directly behind the golden foil. Now, some of them were deflected by a small amount, but most of them literally went through, and their trajectory, their direction was not changed whatsoever. And what did that tell us? Well, that told us that atoms are mostly empty space. And that's the model, that's the nuclear model. We have a small nucleus, and then we have tiny, absolutely tiny electrons, and everything in here is actually empty space. Because if we had full space, if all of that was filled, then everything should be slightly deflected. Everything should be slightly deflected, and that's what could possibly happen if the model was indeed, Plum pudding model was indeed correct, but that didn't happen. So most particles went straight through, and that means that most of an atom is empty space. Now, the other conclusion of the other observation of this experiment is that some particles were deflected. Now, here we're talking about some particles being heavily deflected, either being shot straight back at the transmitter or heavily deflected onto the film, like I drew here. So what does that mean? Now, let's think about this. So in the current model, the nucleus is positive. Now, alpha particles are also positively charged. I will be making a video on radiation and all these different types of radiation particles, but alpha particles are positively charged, and so is the nucleus. And because these alpha particles are getting deflected, now positive charge will deflect other positive charge. So that's how we can tell that nucleus is positively charged, because alpha particle was deflected. So positive, positive. Now, also what this tells us, because those alpha particles were so heavily deflected, it tells us that most of the atom mass is in the nucleus. It tells us that nucleus is, in relative terms, relatively speaking, it's incredibly heavy. Now, if we were shooting at the Plum pudding model, the deflection would be rather small, because they assume that the positive charge is actually not very dense at all. Whereas nucleus is actually a very dense particle in relative terms, talking about the scale here, the atomic scale. So this experiment, so to summarize, this experiment showed us that atoms are mostly empty space because most particles went through, and it also showed us that most atom mass is in the nucleus, and that nucleus must have positive charge, and that is because some particles were so heavily deflected. And this is very important, guys, when you talk about this topic, is to understand exactly what this experiment did. And also, perhaps more importantly, understand what this experiment did not do. So this experiment did not lead to discovery of neutrons. This experiment also didn't really directly lead to discovery of electrons and their alignment around the atom, even though it was hypothesized by Rutherford that this is what atoms should look like. It wasn't confirmed by this experiment. It wasn't confirmed that these electrons should be at such distances from the nucleus and that they are orbiting it in such fashion. This was proven later on by further experimentation. And this experiment did not in any way, shape or form tell us anything about neutrons. Neutrons were discovered much later on, 20 years later if I am correct. So this is important to understand what this experiment did and what did it not do, and how these things were proven by this experiment, because those are the kind of things that are actually interesting to talk to, but also these things will come up on exam, especially I've seen in some more recent papers, they really do like putting the question about this experiment. So make sure you guys learn this. If you need to watch this video twice, make sure you watch it. And thank you very much for watching my videos. I really appreciate when you guys watch my videos. That's why I love doing this. And if you think this video helped you, give me a thumbs up. And if you want to stay up to date on some physics and chemistry, biology, and some maths video like this, make sure you hit the subscribe button below. Don't be shy. Thank you very much again for watching, and see you next time.